When we think about biodiversity, we might picture rainforest, teeming with plant and animal life, clean oceans full of corals and fish, or vast undisturbed grasslands. But these beautiful images of nature and biodiversity are becoming increasingly rare, as biodiversity declines due to human impacts. To learn more about biodiversity and its importance to humans, we spoke with world-leading ecologist Professor Peter Reich from the University of Minnesota and the University of Michigan. Peter shares his outlook on the future of biodiversity, its challenges and questions we need to answer to tackle the biodiversity crisis. Peter, why is biodiversity important?
That's a great question. Biodiversity matters to the way nature functions, but nature itself doesn't care about biodiversity because nature doesn't care about anything. But we as humans should care about biodiversity because of all it does to support the functions and integrity of nature and all that nature does for us. And this occurs in many, many ways. But to make it short and simple, biodiversity helps nature be resilient and productive in the face of all the variation that goes on with climate and with nature itself, and that we rely on that for food, for regulation of climate, for regulation of water flow, and for many other things.
So we often hear that biodiversity is declining, but what does it actually mean, and how do scientists measure it?
That's a great question also. And I think there's two main things I'm going to touch on here. First, and this is what most people think about, is that species are going extinct, which is true and is a great concern. All around the world, species are going extinct, and these are species we don't want to lose from the pool of potential genetic materials for future nature and for future human use of nature. But most of my own work actually isn't focused on that kind of biodiversity loss. And let me back up. That kind of biodiversity loss is measured by trying to keep track of species all over the world, all kinds of species on land and in water and in other contexts, and finding species that are rare and then trying to keep track of whether or not they disappear entirely. When I think about biodiversity and it's important to humans, it's at a completely different scale. And that's at the scale of a given hectare or the size of your backyard or a patch in a forest where individual plants tend to interact with each other. And over time, human use of the landscape and a disturbance of nature has led to what I call simplification of ecosystems, so that any given patch of forest or grassland might have 7 species in the size of a backyard rather than 12 species. And it's that simplification, not loss of species forever, but local extinctions that are causing our systems to become simplified. And the way we measure that is somewhat similar in the sense that we, as scientists, will census or monitor the vegetation and the composition of species on tracts of land ranging from a square meter to a hectare to a square kilometer with various kinds of measures, and repeatedly do that and keep track of those local biodiversity changes.
Mm-hmm. Peter, you devoted your career to biodiversity and biodiversity research. So what are the biggest changes you've seen in your career in this space so far?
Well, actually, because I've been working at this for quite a long time, when I was starting, there was very little research on biodiversity. And the research that existed was mostly worried about particular species extinctions, the whole concern for the simplification of ecosystems or biodiversity loss at an ecosystem scale really only started when people took up early ideas from people like Darwin, in fact, that worried about the fact that when you have fewer species in any given land area, small tract, that you would have less productivity and less stability and less resilience. And so some of the early experiments that I participated in, led by Dave Tillman, but also by me and others, were some of the early experiments to test this, and people have been using observational studies as well. And now there's hundreds of experimental biodiversity experiments around the world in grasslands and forests and agricultural systems. And there's also dozens of networks trying to assess biodiversity, local biodiversity change across regions of the globe, and look at what the impacts of that is on biogeochemical cycling, on ecological health, and on ecosystem services. Some of the tools have changed that allow us to assess things differently. At the opposite ends of the spectrum, at the broadest scale, remote sensing, both low resolution and high resolution, has enabled us to track vegetation better than we could on land because you can't get everywhere, it's too expensive to go everywhere. And we're learning how to make those measurements more accurate. And at the other end of the scale, molecular techniques have allowed us to do things like monitor and track soil microbial diversity and other kinds of microbial diversity in a way that was simply not even it's not at all possible in the past because we could hardly culture these organisms at all. And so that's revolutionized microbiology research from an ecological and biodiversity context.
Yeah, so when we look forward, what do you think are now the biggest questions science need to answer in biodiversity research?
How do we translate what we've learned about biodiversity and its properties and its effects on ecosystems to how we manage the landscape, whether we're talking about agriculture, forests, grasslands, or others? So in essence, we understand the role biodiversity plays in maintaining productivity and stability and resilience. How do we encourage that in both managed and unmanaged systems to keep them healthy for our purposes and to keep that happening in the future, including things such as acquiring and sequestering carbon to slow climate change?
Yeah, so in a nutshell, Peter, do you feel optimistic or pessimistic then about the future of our planet?
Both. I'm very pessimistic in the near term because I think many countries, including mine, are going in the wrong direction in terms of how we're going about interfacing with nature and going the wrong direction in terms of not helping nature help us. But in the longer run, I am actually optimistic because I think both social norms will do change over time, and these will change, but also biodiversity loss actually is going to hurt us economically, and economics is a great driver of human activities at both individual scales and business scales and national scales. And sooner or later, solving climate change and biodiversity crises will be required to sustain economies. So sooner or later, greed as well as good intentions will turn things around. And I think, unfortunately, it won't be for another 10, 20, 30, or 40 years, and because it's also going to take time to make it happen. But I think it will happen, and unfortunately, nature will take a hit along the way, and the poorest people on Earth, the most vulnerable people, will also take a hit because they're the ones who rely on nature the most and are most vulnerable. So that will be a tragedy, but I do think that in 50 or 100 years, people will be able to look back and say, hey, we've either solved this or we're moving in the right direction.
So if we can focus a bit longer on the optimistic future for our planet, let's say, as you said, in 50 or 70 years, what features of such a planet will have in terms of biodiversity?
Well, some things are actually, I think, quite interesting. The world is continuing to get more and more urbanized, and we can actually grow a lot more food per hectare than we could in the past. So we actually have the possibility of having more unmanaged nature restored or allowed to restore itself around on the planet. And so I think we can actually have more mature and quasi-wild ecosystems all around the planet. And we can have agriculture, which is really smart and which has low input, but is very, very productive in a way that it's done in a way to minimize climate impacts. But for instance, having a completely different agriculture than we do now, where it's dispersed in and among where people live, and that it also takes advantage of biodiversity to make it more productive, more resilient, and require lower inputs.
Yeah. Thank you so much, Peter.
Thank you.